Speed Maths 10. Speed, distance, time. Basic concepts of speed, distance, and time. The speed of an object describes the distance traveled divided by the time taken to cover the distance. Speed is directly proportional to distance and inversely proportional to time. Average speed. Case 1. When the distance is constant, average speed equals 2xy divided by x plus y, where x and y are the two speeds at which the same distance has been covered. Case 2. When the time taken is constant, average speed equals x plus y divided by 2, where x and y are the two speeds at which we traveled for the same time. Relative speed. When two objects are moving in the same direction, the relative speed between the two objects is the difference between their speeds, that is, x minus y. When two objects are moving in the opposite direction, the relative speed between the two objects is the sum of their speeds, that is, x plus y. The total difference in time for two journeys for given two different speeds for traveling certain distances is del t is equal to d1 by s1 minus d2 by s2. When the total difference in time for two journeys and two different speeds for traveling certain distances is distance d is equal to s1 s2 divided by s2 minus s1 into del t. Model 1. Time taken. Example 1. Running at 4/7 of his usual speed, a man covers a certain distance in 28 minutes. Calculate the time taken by the man to cover the same distance, running at his usual speed. The usual speed to current speed ratio is 7:4. However, speed is inversely proportional to time. Then the usual time to current time ratio is 4:7. These ratios can be used to solve the problem. According to the problem, a man covers a certain distance in 28 minutes. That is, the current time 7 represents 28 minutes. Then calculate the usual time for, in this case, 7 multiplied by 4 equals 28. Then, multiplying this multiplication factor 4 by the usual time 4 yields the correct answer of 16 minutes. Example 2. Two runners started running simultaneously from opposite ends of a bridge. But a slower runner takes 5 seconds more than a fast runner to cross the bridge. If the speed of the fast runner is double the slower one, then find the time taken by a slow runner to cross the bridge. According to the problem, the speed of the fast runner is double of the slower one. So, the slower runner's speed to the faster runner's speed ratio is 1:2. However, speed is inversely proportional to time. Then the time taken by the slower to faster ratio is 2:1. That is, the time difference between the runners is 1 representing 5 seconds. Then, calculate the time taken by slow runner 2 is 10 seconds. Example 3. Walking at the rate of 4 kilometers per hour, a man covers a certain distance in 2 hours and 45 minutes. Running at a speed of 16.5 kilometers per hour, a man will cover the same distance in. Let's start by calculating the distance covered by the man while walking. First, we convert 2 hours and 45 minutes into a fraction. An hour is divided into 60 minutes. By dividing 45 minutes by 60 and then adding 2, we can convert the given time in minutes to hours. Time 2 hours 45 minutes equals 11 by 4. The distance equals speed multiplied by time. The distance equals 4 into 11 by 4. 11 kilometers is the distance. We can now use the same formula to calculate how long it would take a man to run the same distance at a speed of 16.5 kilometers per hour. Time is equal to distance divided by speed, which is 11 kilometers by 16.5 kilometers per hour. In order to convert minutes to hours, multiply the result by 60. As a result, the man would cover the same distance in 40 minutes. Example 4. If a car runs at 45 kilometers per hour, it reaches its destination late by 10 minutes, but if it runs at 60 kilometers per hour, it is late by 4 minutes. What is the correct time for the journey? First, we convert minutes into hours. 10 minutes equals 10 by 60 hours. 4 minutes equals 4 by 60 hours. The difference in time del t is 10 minus 4 by 60. When the total difference in time for two journeys and two different speeds for traveling certain distances is Distance of the journey is equal to S1 S2 divided by S2 minus S1 into del T. Substitute these values in the equation, we get a distance of 18 kilometers. According to the question, a car runs at 45 kilometers per hour and covers a distance of 18 kilometers. We can now use the speed, distance, and time formula to calculate time taken to complete the distance of 18 kilometers with 45 kilometers per hour. Time is equal to 18 divided by 45, and this fraction is multiplied by 60 in order to convert time in hours to minutes. So 24 minutes is required to cover the 18-kilometer distance. However, the car reaches 10 minutes late. The difference between 24 minutes and 10 minutes is the actual time taken to cover the distance, which is 14 minutes. Model 2. Distance covered. Example 1. Sachin can cover a distance in 1 hour 24 minutes by covering 2/3 of the distance at 4 km per hour and rest at 5 km per hour. The total distance is, let 3x be the total distance that Sachin needs to cover. Then, he covers 2x the distance at 4 km per hour and 1x the distance at 5 km per hour. The time taken to cover a distance is 1 hour, 24 minutes or 7 by 5 hours. We can frame the equation based on this information using a basic formula. T is equal to distance divided by speed. The total time taken to cover a certain distance is the sum of the time taken. 2x by 4 plus x by 5 equals 7 by 5. Solving an equation for x, we get x is equal to 2. Substitute this x value to compute a total distance of 3x, we get 6 kilometers. Example 2. A man goes to his office at 30 kilometers per hour and reaches 15 minutes late. The next day, he goes at 45 kilometers per hour and reaches 5 minutes earlier. Calculate the distance between home to office. The difference in time del T is 15 minus of minus 5, which is 20 minutes. We convert minutes into hours. 20 minutes equals 1 by 3 hours. When the total difference in time for 2 journeys and 2 different speeds for traveling certain distances is distance of the journey is equal to S1 S2 divided by S2 minus S1 into del T. Substitute these values in the equation, we get a distance of 30 kilometers. Example 3. Ram goes to his school at the rate of 15 kilometers per hour and reaches 15 minutes late. The next day, he goes 20 kilometers per hour and reaches 5 minutes before. Calculate the distance between his home to school. The difference in time, del T, is 15 minus 5, which is 20 minutes. We convert minutes into hours. 20 minutes equals 20 by 60 or 1 by 3 hours. When the total difference in time for 2 journeys and 2 different speeds for traveling certain distances is distance of the journey is equal to S1 S2 divided by S2 minus S1 into del T. Substitute these values in the equation, we get a distance of 20 kilometers. Model 3. Usual speed concept. Example 1. Due to bad weather conditions, an aircraft reduces its speed by 200 km per hour and reaches 30 minutes late on a flight of 1200 km. Calculate the usual speed of the aircraft. Let us assume that the usual speed of aircraft is s and aircraft reduce its speed by 200 km per hour, which is s minus 200. The difference in time del T is 30 minutes or half an hour. The distance of the journey of 1200 kilometers is equal to the product of the usual speed and the new speed divided by differences in speeds into del T. Substitute the usual speed s and the new speed s minus 200 in the equation. Solving s, we get the speed of 800 kilometers per hour. Example 2. A man covers a certain distance on a scooter and travels 3 km per hour faster. He could have taken 40 minutes less, but if he decreased his speed by 2 km per hour, then he become 40 minutes late. Find the distance. Let us assume that the usual speed of the scooter is s. A man travels 3 km per hour faster than the usual speed, which is s plus 3. A man travels 2 km per hour slower than the usual speed, which is s minus 2. The difference in time del T is 40 minutes, not 80 minutes. We convert minutes into hours. 40 minutes equals 40 by 60 or 2 by 3 hours. Distance of the journey is equal to S1 S2 divided by S2 minus S1 into del T. Substitute S and S plus 3 values in the equation. Similarly, substitute S and S minus 2 values in the equation. In order to find the usual speed of S, equate these two equations and solve for S. We get the speed of 12 kilometers per hour. Substitute the speed of 12 kilometers per hour into the first equation. We get a distance of 40 kilometers. Model 4. Average speed concept. Example 1. Rahul goes to his office at 20 kilometers per hour and reaches at 10 a.m. The next day he goes at 30 kilometers per hour and reaches at 8 a.m., but he wants to reach 9 a.m. What must be his speed? We know that Rahul reaches his office at 10 a.m. on the first day, and at 8 a.m. on the second day. We need to find the speed at which Rahul should travel to reach his office at 9 a.m. We solve this problem in a smart way. The average between 8 a.m. and 10 a.m. is 9 a.m. So, let's use the given concept to find Rahul's average speed during the entire journey from his home to the office. Substituting the values of 20 kilometers per hour and 30 kilometers per hour in the formula for average speed. Hence, Rahul should travel at a speed of 24 kilometers per hour to reach his office at 9 a.m. Example 2. A person travels from A to B at a speed of 2.3 by 4 km per hour and comes back from B to A at a speed of 1 by 3 km per hour. Find his average speed for the whole journey. First, convert mixed fractions into irregular fractions. 2.3 by 4 is 11 by 4. 1 by 3 is 4 by 3. Average speed is equal to 2xy divided by x plus y km per hour. Substituting the values of 11 by 4 km per hour and 4 by 3 km per hour in the formula for average speed, we get 88 by 49 km per hour. Convert kilometers per hour to meters per second using the fraction 5 by 18. The average speed for the whole journey is 0.5 meters per second. Model 5. Relative speed. Example 1. A thief was noticed by a policeman from a distance of 200 meters. The thief starts running and the policeman chases him. The thief and the policeman run at the rate of 10 kilometers per hour and 11 kilometers per hour respectively. The distance between them after 6 minutes will be relative speed of policeman with respect to thief is equal to 11 minus 10 km per hour. Convert kilometer per hour into meter per second by multiplying 5 by 18. Also multiply by 60 so that the time is seconds is converted to minutes. The relative distance covered by policeman is now 6 minutes. In the speed, distance and time formula, substitute these values. Distance d is equal to 11 minus 10 into 5 by 18 into 60 into 6. The distance between the policeman and thief after 6 minutes will be 100 meters. Model 6. Meeting point. Example 1. Two trains started from station with 60 km per hour and 75 km per hour at 6:30 a.m. and 7 a.m. respectively. Find the distance from station A to the point where both train will meet. The first train leaves at 6:30 a.m. The first train travels at a speed of 60 km per hour. The first train covers a distance of 60 km in 1 hour. The first train covers a 30 km distance in half an hour. The time difference between first train and the second train is half an hour. When the second train departs at 7 a.m., the first train has traveled 30 km distance. The relative speed of two trains when travels in same direction is 75 minus 60 km per hour. The time required to travel 30 km is 30 divided by 75 minus 60, which equals 2 hours. The distance from station A to where the trains meet is 75 into 2 equals 150 kilometers. As a result, the trains will meet 150 kilometers away at station A. Example 2. The distance between Mohan and Sohan is 500 meters. They started walking towards each other at the rate of 10 km per hour and 15 km per hour respectively at 7 a.m. Find at what time they will meet and also find the distance from origin of Mohan to the meeting point. When traveling in opposite directions, the relative speed of Mohan and Sohan is 15 plus 10 km per hour. The time required to travel 500 meters is 500 divided by 15 plus 10. It is noticed that the distance is expressed in meters but the speed is expressed kilometers per hour. As a result, multiply 18 by 5. To convert kilometer per hour to meter per second, the time required to travel 500 meters is 72 seconds. The distance from Mohan's origin to the meeting point is 10 into 72 into 5 by 18 equals 200 meters. As a result, Mohan and Sohan will meet at 200 meters. The correct answer is option B. 7 hours 1 minute 12 seconds, and 200 meters. Model 7. Forward, backward problems. Example 1. An insect moves forward by 4 centimeters in 1 second and in next second it moves backward by 2 centimeters. Calculate the time taken by insect to cover distance of 20 centimeters. An insect moves forward 4 centimeters in the first second. An insect moves 2 centimeters backward in the next second. This is the pattern. After 2 seconds, the total distance traveled by an insect, both forward and backward, is 4 centimeters minus 2 centimeters, equaling 2 centimeters. Similarly, the total distance covered by an insect 16 centimeters in both directions is 16 seconds. An insect moves forward 4 centimeters in the next second. 16 plus 4 is 20 centimeters. Distance covers by 16 plus 1 or 17 seconds. Model 8. Cart problems. Example 2. The circumference of the front wheel of a cart is 40 feet long and that of the back wheel is 48 feet long. What is the distance traveled by the cart when the front wheel has done 5 more revolutions than the rear wheel?